Okay, today we are going to get started with our probability and statistics unit. And the first thing that we're going to talk about is one way that we might see some information organized. And that's to use something called a two-way table. So that's what we're going to look at for today. Sometimes these are called two-way frequency tables. But the idea is that I am organizing my information based on two categories, okay? Two sort of descriptors that I'm using. So for the two-way table that we can see here, we're looking at breakfast habits for freshmen and seniors. So our two categorical variables or two categories of data are the year that someone is in school, a freshman or a senior. If I wanted to, I could add sophomores and juniors here. And then whether or not they eat breakfast. So they eat breakfast or they skip breakfast. Those are my two categories of information. So my variables are class and breakfast habits. So what we're going to do is use the information in our two-way table to determine some probabilities. Example 1 says, what's the probability that a student eats breakfast? So somebody who eats breakfast. And then that's all I know. What's the probability that they eat breakfast? So that tells me that since I know no other information, I'm looking at out of everybody, out of all the students, who eats breakfast? What's the probability that if I were to just grab a random student in the hallway that they eat breakfast? So my breakfast eaters make up 58 students out of 92 total students that we surveyed. For probability, we're going to leave this as a decimal. So when I divide this, we would get 0.63, and we'll leave our answers today as decimals rounded to 2 places. Now, remember that this does represent a percentage. So what's the probability that a student eats breakfast? I could say the probability is 0.63, or I could also say I would expect 63% of students surveyed to say that they eat breakfast. For example 2, what's the probability that a randomly selected student is a senior? Another way I could phrase this, randomly selected student, means I'm looking out of everybody that I surveyed that I happen to pick a senior. So I'm still out of my total group here, out of everybody, all 92 students that I surveyed. What's the probability that I pick a senior? So I'm looking at a different category now. So I need to look at all the seniors. I have 48 seniors. 48 out of 92 would give us 0.52. And again, I'm going to leave this as a decimal rounded to 2 places, but this means a little over half of the students that I surveyed are seniors, which should also make sense based on the totals that I got here for freshmen and seniors. Pretty close, 44 and 48, a little over half of them were seniors. Now, I want you to notice that both of these initial probabilities were based out of everybody. If I looked at my whole group of students, if I had them all in a room, and I just selected someone at random. For the next few probabilities that we're going to look at something called conditional probabilities. So let's take a look at what those mean. So for example 3, what's the probability that a freshman student eats breakfast? This time, I'm not looking at out of everybody, I'm looking at out of freshman students. So the first thing I know is not that I've got all of my surveyed people in a room, it's that I'm talking specifically to a freshman. And then knowing that I'm talking to a freshman, what's the probability that that person eats breakfast? So on top, this is also going to be a little different. It's not just everyone who eats breakfast, because everyone who eats breakfast is not a freshman. I need to make sure I'm picking someone who's a freshman and eats breakfast. So total freshmen would be 44. And then freshmen who eat breakfast would be 36. So 36 out of 44 this time gives me, again, decimal rounded to 2 places, 0.82. What's the probability that a freshman student eats breakfast? So if I just round up all the freshmen that I surveyed and look at the probability that randomly selecting one of them would give me somebody who ate breakfast, I've got 0.82, about an 82% chance, pretty high, which again should make sense. Most of our freshmen reported that they eat breakfast. And then for example 4 here, what's the probability that a student is a senior given that they skip breakfast? So this is another key word here, another way that I could phrase a conditional probability, given that they skip breakfast. So I know some information about this student already. I know that they skip breakfast. They do not eat breakfast. So I'm not looking at out of everybody. I'm looking at out of the people who skip breakfast. So if I hop back up to the top here, I'm looking at 34 people here, not everybody, but the 34 who skip breakfast. So out of the 34 who skip breakfast, what's the probability that they're a senior? Okay, so again, I need to be careful here. I'm not picking all the seniors. I have to go to that skip breakfast column or row, I guess, and make sure that I'm selecting only the seniors. So skip breakfast and as a senior, that's 26. So 26 out of 34 gives me 0.76. Again, should make sense that we've got a larger number here, because if I look at my table, most of the people who are skipping breakfast are seniors. So I would expect this to be a large percentage. I would expect this to be a pretty decent probability. So these are what are called conditional probabilities, because we know some information about the student to start. In that problem, for example 3, we knew that they were a freshman. For example 4, we knew that they skipped breakfast, but we knew some information to start. I wasn't going in blind. I was going in knowing that this person already meets one of these categories. They're already in this part of this category. Okay. One more thing I want you to keep in mind when we talk about probabilities, again, we're going to keep them as decimals rounded to a few places. Read your directions carefully on your different work, but we're going to keep them as decimals unless it specifically says percent. And the other thing I want you to remember is that for probabilities, we're always looking at values between 0 and 1. I should never have a probability that's less than 0. I should never have a probability that's greater than 1. If I get anything less than 0, if I get a negative value, then I need to go back and double check my work. It's okay to have very small values. We had some larger probabilities here, everything greater than a 50% chance, but that was the particular problem that we looked at. If I've got anything negative, I need to go back and double check my work. If I get anything greater than 1, I need to go back and double check my work. If you get something greater than 1, it probably means your setup might be flip-flopped. So just be careful with those, okay? And again, make sure you read your problems very carefully, especially when we could be looking at conditional probabilities. It's important to make sure that I am selecting out of the correct group. So if I need to select out of everybody, I make sure that bottom number is everybody. If I know something about this group already, I need to make sure that I narrow it down to just that group. Okay, and those are two-way tables and conditional probability.